Good afternoon. On behalf of the authors, I would like to present our research paper, Ultra-Compact Optical Lens Notification based on 4x4 multimode interference couplers using silicon hybrid plasmonic waveguides. My name is Trung Thành Nghi from Vietnam National University, Hanoi, Vietnam. In this paper, I would like to share with you new structures based on ultra-compact cascade multimode interference with CS-AMI structures using high hybrid plasmonic waveguide in silicon for all optical NAND gate, and a very compact footprint of 3 by 16 micrometer can be achieved. And we saw that contrast ratios for logic 1 and logic 0 for the AND gate are about 20 dB for an ultra high bandwidth of 70 nanometers, and a very large fabrication tolerance can be achieved. In the literature, optical noise gates can be realized by some approach. For example, people can use nonlinear materials using Meissner interferometers, using semiconductor optical amplifiers. There are some research based on AMI using photonic crystal, and people also can use periodic waveguide and plasmonic waveguide to realize the optical waveguide. And in the literature, we present some structures based on only multimode interference. For example, we use 2x2, 3x2, and 5x5 multimode interference couplers to realize all optical waveguides. But in this paper, I show you we use a very compact waveguide using silicon hybrid plasmonic waveguide, and this kind of waveguide present and proposed by Professor Dao-Xin Daiwo at Zhejiang University, and this is the latest paper by this research group, just published in 2021. Here's our structures based on two multimode interference couplers cascades. One is based on 4x4, the second one is based on 2x2, and is connected together. And we use a hybrid plasmonic waveguides, and in the cover collecting, we use AG materials. This is the cross-sectional views of the structure, and we use the width of the input waveguides is 200 nanometer for single mode operation. And by using some matrix calculation, we can use the output port at port 2 to implement the NAND gate, and the relation between input and output expressed by this equation. And using the EME simulation, we can calculate the effective refractive index of the hybrid plasmonic waveguide, and we can choose the width of the sum of the input and output waveguides and the width of the multimode waveguide for the design operation. And in our structure, we need to implement the phase shift or pi radian, and we use the 1x1 multimode interference coupler to implement this phase shift. And here is the FDTD simulation of the phase shifter And from this simulation, we can calculate the length of the facet to achieve the desired facet for two width of 100 and 1200 nanometer. And based on mode propagation, we can calculate the fields going through the multimode interference coupler, and is expressed by this matrix. And in this research paper, we use the phase encoding of information for inputs and amplitude encoding is used for output. And by properly selecting the input and the width and the length of the multimode interference coupler, we can calculate the matrix of choose multimode interference coupler here. And by using the phase encoding at input and amplitude encoding at output, we can achieve the land noise gate from the above structures. And here is a truth table of the realized NAND noise gate using our structure. And we use EME simulation for 4 cases: input 0, 0, input 0, 1, input 1, 0, and input 1, 1. And we can realize the NAND gate, all optical NAND gates, using this structure with very compact footprints. And here the dimension of this structure is 3 by 16 micrometer. And by using EME simulation, we can find the optimal length of both 4x4 and 2x2 MMI here. And we calculate the bandwidth and contrast ratio of the structure. And from this simulation, we saw that a high bandwidth of 70 nanometer can be achieved, and a contrast ratio about 22 to 25 dB can be achieved. Okay, in this paper, we have presented a new structure to implement all optical LAN noise gate based on silicon hybrid plasmonic waveguide. And this plasmonic waveguide can provide a very compact footprint and large bandwidth and very large contrast ratio. And this structure can be used for optical label swapping recognition in optical packet switching network or on-chip signal processing application. Okay, thank you very much for your attention.